All right, welcome back, AP Calc students. Time for more FRQs. Today we are looking at AP Calc AB. The year is 2019, and it is question number 6. So, question number 6 means we have a non-calculator question, and this question falls under the category of function building combined with sort of a potpourri of calc skills and vocab. So it's a little bit of a combo question. So let's see what we're given, and this one's a little bit of a puzzle too. So this is kind of fun to sort of interpret what they're looking for. So here's what we're given: functions f, g, and h are twice differentiable functions with g of 2 equaling h of 2, and those are both equal to 4. The line y equals 4 plus 2/3 x minus 2 is tangent to both the graph of g at x equals 2 and h at x equals 2. So I'm just going to jot down what they have over here, and we'll probably wind up erasing this, but just for note purposes here, it looks like they're giving us 3 functions to play with here, so f, g, and h. And what they're telling us here, g has a coordinate at 2, 4. And h also has a coordinate at 2, 4. Now I'm writing it as a coordinate instead of the function notation that they did. And f, we don't have any information about that yet. But they also said that both of the tangents at 2, 4 for both of these are equal to this line. Y is equal to, and I'm going to write this a little bit different too, y is equal to 2/3 x minus 2, and we'll have a plus 4 on the end. So I think you guys can see that they wrote this in point slope form, and prior to moving the 4 over, it was over here, and this would just be point slope 4. So here, right here, is the slope of the tangent, or is the equation of the tangent. So I'm going to write equation of the tangent here. All right, and now we're going to see what they want us to figure out. And so here's what we know. So starting here with A, they say, we would like you to figure out what is h prime at 2. Or in other words, what's the derivative at 2? Well, we don't have a function here. We just get told, the only thing we know is that h has a coordinate at 2, 4, and the equation of the tangent at 2, 4 is equal to this. Well, what this is testing you on is, do you know the most basic definition of a derivative? Not the formal one, the slang one. And what's a derivative? Slope of a tangent. Well, here's the tangent, and there's the slope. And at 2, 4, the slope of the tangent is 2/3. This was nothing. There was no work to do. It was just knowing your vocab and identifying it. That's how easy that question was. Just knowing that derivatives are slopes of tangents, and this was evaluated at the coordinate 2, 4, and based on the given information, that's the point of tangency. There's your slope. Done. Part B. Part B says, well, now here's the function build part. They give us a third function, or a fourth function here. And they say a is a function. A of x is given by this equation, 3x cubed times h of x. And they say, write an expression for the derivative and then evaluate it at 2. So what they're testing you on here is just, do you know your product rule? So if you want to figure out a prime, you just say, okay, well, derivative of the first, so there's the first term, and here's the second. So the derivative of the first would be 9x squared times the second, h of x, plus the first, back to 3x cubed, times the derivative of the second, which would be just h prime of x. So that's actually worth a point, just finding that. And now it's asking us to evaluate that at 2. So a prime of 2, 2 squared here is 4, 4 times 9 is 36. So we have 36h of 2 plus 2 cubed is 8. 8 times 3 is 24. So we have 24h prime of 2. And now we have to see what we can figure out here. Well, h of 2, that was one of the values that was given in the given information. So this is actually 4. So it looks like we have 36 times 4 plus 24 times the derivative of h at 2, which was the prior question, which is 2/3. And this is all a prime of 2. So little longer multiplication here. 4 times 30 is 120. 120 plus 24. We're getting 144 here. And then we're getting plus 16. 2 times 8 is 16. And then our final answer here is equal to 150. So a prime of 2 is equal to 150. All right, so they asked us to find the derivative, which was right here at this step. So there's the a prime, and then we evaluated it too. And that's what they asked for. So part B is now done. Now let's get to C. C, definitely a little more complicated of a question, and we're going to have to take our time, slow down. Might have to do a little review here. And I'm actually going to sketch a potential graph just to help in the understanding. So they now say that the function h satisfies this condition, and they say, well, h of x is actually x squared minus 4 over 1 minus f of x, and f of x is cubed. And they say this satisfies, h satisfies this function for all values of x except x equaling 2. It is also known, it says, that the limit as x approaches h of 2 can be evaluated using L'Hopital's rule. Interesting. Now it says use the limit to find f of 2 and f prime of 2. So it's a little bit curious here, is that they're asking us to find f of 2, but they're giving us information about h of 2. And so this one definitely is more of a puzzle, and you got to be careful and think through what they're showing you. So what I'm going to do is put some work over here because I'm out of distance here, and so I'm going to erase this, and we'll refer to it again here a little bit later. But I'm going to write down all the things we know here about part C here. So let's see what we know. We know that, I just erased this up here, but we know that h of 2 is equal to 4, and the way I wrote that was a coordinate 2, 4, and that's really important, because if you have a coordinate 2, 4, and it says these are twice differentiable, and the function satisfies this, and it's known that the limit here can be used, can be evaluated using L'Hopital's rule, we know that we're actually going to get 4 for our answer. So let me illustrate what I mean there. So what we know is we know that the limit as x approaches 2 of h of x, and h of x is this goofy function we got here. So we know that the limit of this is equal to 4. So I want to pause and just make sure you let that sink in and how we know that. So we know this was given information that h of 2 is equal to 4. They tell us it's twice differentiable. And so, therefore, and I know if I have a coordinate here at 4, the limit as x approaches 2 from both sides has to give me 4. And so I know that this has to be true. Well, you guys can see right away, if you substitute 2 into the function, you can see the numerator is 0. And if you put 2 into the bottom, you'd have to know what f of 2 is. Well, we don't know what f of 2 is. In fact, that's what they're asking to find in the question. But here's the big hint. The hint is in the second part of the question. Or in the second statement here in the question. It says, L'Hopital's, it is known that the limit as x approaches 2 of h of x can be evaluated using L'Hopital's rule. Well, that's really helpful, because that means that if we go ahead and try to do this, it's going to be indeterminate. So we know that it equals 4, and because of the hint they gave us, we also know that this is true. We also know that the limit as x approaches 2 of x squared minus 4, write that a little neater here, of x squared minus 4 of 1 minus f of x cubed would equal 0 over 0 if we tried to do a Nike limit. So let that sink in here. Here's what we know. And never having done a question quite like this, this can be a little more confusing than it really is the first time through. So we know that we have a coordinate at 2, 4, and we know the limit as we approach 2. Therefore, we know that y value has to be 4. The limit's a y value being approached. So I know two things at the same time. I know the limit as x approaches 2 of h of x is equal to 4, but I also know the limit as x approaches 2, if I go there directly, it's going to give me an indeterminate set because it says L'Hopital's rule could be used. So these two things I know are true at the same time. If you're okay with that, then you can see pretty clearly if you put 2 into the numerator, that's not surprising. 2 squared is 4, 4 minus 4 is 0. But what this enables us to do is figure out what f of x must be to make this true. So if L'Hopital's rule can be used here, that means this has to give me a 0 in the denominator. So by the second hint they gave us here, here's what we know. 1 minus f of x cubed has got to equal 0. So I'm going to write, so we know. Okay, so we can solve this. So I'm going to add this to the other side, cube root both sides. I think you can see pretty clearly that f of x is going to have to equal 1 for this to work. And the x value we're approaching is 2. So f of 2 has got to equal 1. That's the only way this could work. So again, you try to do a Nike limit, you put 2 in there, you get 0. That means f of 2 is going to have to equal 1 in order to make this work. So we have just figured out that f of 2 has got to equal 1. Interesting. Now, the next thing they want to know is they want to know the derivative at 2. So we've got f of 2, we need to figure out what f prime of 2 is. Well, if we know that f of 2 is equal to 1, let's see what we could figure out on the next part here. So if we use the limit as x approaches 2 of the original here, getting 4, let's go ahead and apply L'Hopital's rule and see what we could discover. And this is the part that, unless you've done one of these problems before, you might just be at a dead end and go, I don't know what to do. So here's the little trick. What I want to do is go back to here. I want to go back to the beginning and kind of play dumb. And let's try it here. So if I say the limit as x approaches 2 of x squared minus 4, 1 minus f of x, and that is cubed, okay? I know that that's going to be indeterminate, okay? Well, if that's going to be indeterminate, L'Hopital's rule is going to work. So I'm actually going to do L'Hopital's rule. So after this step right here, I'm going to apply L'Hopital's rule. So the part that's a little bit confusing first time through here is, I knew up here, it told me that it qualified for L'Hopital's rule. That's how I knew this had to be a 0. So we know that that has to be a 0, and it allowed me to figure out that f of x, or in this case f of 2, would have to equal 1. But I haven't applied L'Hopital's rule yet, till now. So now that I apply L'Hopital's rule, if I take the derivative of the top over the derivative of the bottom, we're going to see what we get. So I'm going to say, okay, according to L'Hopital's rule, I take the derivative of the top, which is just 2x, all over the derivative of the bottom. Now you got to be careful here. We have a little chain rule here. Derivative of 1 is 0, but I would have negative 3 times f of x squared times the derivative of f of x. So there it is. That's L'Hopital's rule. Well, what I know is that it's going to equal 4. So it's a little bit confusing here, but I'm going to apply L'Hopital's rule and with using the derivative process, and I know I have to get a 4 here. So if I'm going to get a 4, let's start filling in values now. So I'm going to 2, so I'm actually going to apply this like a Nike limit. I know it's got to equal 4. So I'm going to put 2 in there, so I get 2 times 2 over negative 3 times f of 2, and I'm going to have to square that, times f prime of 2. And that's equal to 4. Now, the whole reason we're doing this is the second part of the question is saying solve for f prime of 2. So if we continue to simplify this, in the numerator here we have 4. And in the bottom, f of 2 we had solved for being 1. 1 squared is 1, so in the bottom here I get negative 3 times f prime of 2. And that is equal to 4 is what we're getting. So what if I multiply both sides by f prime of 2 and divide both sides by 4? So I might wind up erasing some of this to have some space here to do d. So just rewind the video if you need to see that more. So what I'm going to do is cross multiply here. Just multiply both sides by the bottom. I would get negative 12 f prime of 2. I've noticed if I don't do this, I get some silly algebra questions. So I'm just multiplying both sides by the bottom. Now I'll divide both sides by 12. So I get 4 over negative 12 is equal to f prime of 2. And that reduces to negative 1/3 is equal to f prime of 2. Okay. So the first time you see this, you would never, probably, very few students would be able to get this without having seen an example, which is why we do the old APs. And this was just 2019, so there's a chance there could be something like this. So from the top, again, let's see how we figured this out. It says the function, down here, it says this function is equal to 4. For x not equal to 2. And the reason we know that, it says here in the question, let h satisfies the equations for x not equal to 2. And in the equation up here, x of 2 is equal to 4. So that was given. So we were able to then take this and say, oh, well, this thing must equal 4. We're getting this y value here. So the limit as x approaches 4 is equal to 2. Or, sorry, as limit as x approaches 2 of this function is equal to 4 based on our given information. Then the secondary information they said is, it is known that this was evaluated using L'Hopital's rule. Well, L'Hopital's rule, means indeterminate, so we must have been getting 0 over 0. That's the only, it wouldn't have made sense to have infinity over infinity or any of the other indeterminate forms. It had to be this one, and you could see right away it sure enough works for the top. If you put 2 in here and try to Nike limit, you're going to get 0. So you had to figure out how to get a 0 in the bottom, and that's where we got this right here. Solve for f of x. When does f of x equal 1? The only way f of x would have to equal 1 to satisfy this, and that's when x goes to 2. So f of 2 had to equal 1. Mission accomplished. Then we actually did L'Hopital's rule and set it equal to 4 that we knew, and we were able to isolate eventually f prime, and we got f prime equal to negative 1/3. So what I'm going to do is just erase this part right here, and I'm going to put my conclusion right here, up top here, that f prime of 2 was equal to negative 1/3. I'm going to box that. Okay, and then we'll move on to part D. Okay, part D says, it is known that g of x is less than h of x between 1 and 3. K is now our new function that is in between g and h in that same interval. And then it says, is k continuous at x equals 2? Seems like a out of the blue question, kind of, so you have to refer back again to the given information. So if you remember, back in the given information we were told, I had this written here in notes before, but I'm going to write it here. In the given information they say the g function has a coordinate at 2, 4. The h function also has a coordinate at 2, 4. They share a point right there. And so what the question is saying down here, though, is that g of x is less than or equal to h of x in the interval 1 to 3, and k is in between them, but they share this point, which is in the interval. So I think the best way to understand this is, let me just give you a maybe this is what it looks like to kind of get your mind wrapped around it. It's important to look at a graph on this one. So this isn't necessarily what the graph looks like, but it could be. And I think this will help you understand what they're saying. So they're only looking at the graph at between 1 and 3. Okay? So, and we also know that, and this is not to scale here, but they also know that you have a point 2, 4. Both of these functions go through them. And it says g is less than h. So what I'm going to do is just pretend this function came up here and hits that value right there. And I'm going to call this function g. And I have another function coming down here. And it hits this point right here, and I'm going to call that h. And so maybe this is what it looks like. We have two functions. They both share the point 2, 4. And the other piece of information we're given is that g of x is less than h of x in the interval 1 less than x less than 3. And so if you look at that, this little sketch I made satisfies it. So it's known that this is true so far, and then it says k is our new function, and what they tell us is k is in between these two. So k is less than or equal to h of x. It's actually k of x. So k has got to fit in between here somewhere, so I'm going to sketch it. So it's in this same interval, it's between the two, so I'm going to just put it right here. So there's my k function. It's less than or equal to h, but it's greater than g, so it's in between the two. So again, I think this kind of gives you a little bit of an idea of a little better feel for this problem here. Okay. So then now let's look at the question. It says, is k continuous? Is k continuous at x is equal to 2? Okay? Then justify your answer. Now, based on my sketch I made, you would think, well, it kind of looks like it would have to be. And what they're trying to have you notice here is it's not a theorem that gets, we don't spend a lot of time on it, but it's actually a theorem that says if your function is less than or equal to less than one function but greater than the other, and they both share a point like this, k function is getting squeezed in between them, which is telling us that it has to share this point. And so there's a couple different ways you could say your answer. So here's what we would say. We would say, well, if g of x, and this is given, if g of x is less than or equal to k of x, which is less than or equal to h of x, for 1 less than x less than 3. Okay, if that's true, which they told us it's true, okay, we know from above that the limit as x approaches 2 of g of x is equal to g of 2, which is equal to 4, and the limit as x approaches 2 of h of x is just equal to h of 2, which is also equal to 4. So here's the long if statement here. Okay, so I'm going to draw a line here just to get our question out of the way here. So is k continuous at 2? Well, if g of x is less than k of x is less than h of x for x between 1 and 3, the limit as x goes to 2 is g of x, as g of 2 is 4, and the limit as x approaches 2 of h of x, as h of 2 is 4. This is all given information. Then, here's my then statement, then by the squeeze theorem, the limit as x approaches 2 of k of x is equal to k of 2, which would equal 4. So this is a little bit of kind of an obscure theorem. We use it way back in when we find the limit as sine of x over x is equal to 1. We use the squeeze theorem there too. But whenever you have a function in this dynamic, and again, you would never probably think of this without reviewing this particular question. But the squeeze theorem is when you have a function that's in between two, and then they share this point. It's kind of a unique thing. You can kind of see how it's fairly intuitive here that g and h are converging on the same point, and if I tell you that k is between them, it's got to go through there as well. So is k continuous at 2? By the squeeze theorem, well, you can read that. Limit as x approaches 2 of k of x as k is 2 is also equal to 4. Therefore, it's continuous at 4. Therefore, k continuous at 2. The y value is 4, but the x value is 2. Now, if you see that and you're like, well, I don't really think I could have got that, well, not without reviewing this question, you might not have. But there's also then a slightly easier way to do this one. So you might have looked at this and said, well, you could have avoided the squeeze theorem, and you could have said, maybe you could have just been a little more basic with it. You could have said this approach. You could have said, well, I'm going to fit this in down here. You could have just said, well, here's what I know. G of 2 is less than or equal to K of 2, and that's less than or equal to H of 2. And all you did, I mean, it was given in this part of the question if this is true, so you're like, well, G of 2 is less than or equal to K of 2 is less than or equal to H of 2. And G of 2 you guys know is 4, that was given. You could say, so 4 is less than or equal to K of 2 is less than or equal to 4. By substitution, I just replaced G of 2 and H of 2 with 4. And so, how can K be between 4 and 4? It has to equal 4. So you could say, therefore, K of 2 is equal to 4. And if you wanted to complete it, you could say n continuous at x is equal to 2, because it equaled 4 by our statement here. So you could have went the more sophisticated route here with the squeeze theorem, or you could have just went down here and kept it basic. The thing to keep in mind is with the entire AP question, remember, in this year's it was worth 9 points. This last thing right here, even though after you see it, I think there's a lot of logic here that makes it make sense, but this whole part D was only worth 1 point. The bulk of your points came from all of your other basic skills here. So let's kind of quickly review that. For part A, do you know that a derivative is the slope of a tangent? They gave you the equation of the tangent, so the slope had to be 2/3, and sure enough there it was, h prime of 2. There was no work to do, it was just identifying. And then B, did you know your product rule? For the derivative, if you did, you got your points there, and then can you put in 2? You got your points there. So A was worth 1, B was worth 3 points. So you're at 4 points getting A and B, you're just under a half. The bulk of the question, or bulk of the points for this one, came from part C, which without having seen this one before, you might have really struggled, but now that you've seen it, I think it's pretty logical, where you could say, well, they're defining now the H function, and I know that when x is equal to 2 on this, it's equal to 4, because that was given in the information here. So if I know that if my y value at 2 is 4, then I know I can let my limit as x approaches 2 equal 4. And that's just by understanding limits. So you'd say, well, I can take the limit as the x approaches 2 of the function, set it equal to 4. And then they told me that the function was, L'Hopital's rule could be applied. So you say, oh, well, if I know it's equal to 4, but L'Hopital's rule was applied, that meant before I concluded it was 4, I first concluded it was 0 over 0, because I know L'Hopital's rule. And in fact, if you put 2 into the top here, you can see 2 squared minus 4 is 0, and so you'd say, oh, that bottom had to be 0 as well, and that's how we had this little equation here, and we said, oh, well, f of x has to be 1, but it's actually f of 2 because we're going 2, so I knew that. That was the first part of it. Then the second part was going back to actually performing L'Hopital's rule, derivative of the top or the bottom, and saying, oh, well, now it equaled 4. So understanding that this limit was 4, but before it was 4, it was also 0 over 0, and just knowing how to manipulate each situation for it, and getting your values. And so this one, when we set it back equal to 4, we were just isolating f prime because we had to solve for it. And if you recall that we erased our little arithmetic here, so if you have to go back and watch the video there. And then part D, 1 point. So if D really threw you, not a big deal. You get 8 out of 9 points, you're doing fine. Okay, so there it is, AP Calc AB 2019, number 6. All right, thanks for watching. We will see you next time.